Now that you know how to factor, let's show why we need the factor and how we're going to use that. This is a problem from the 1-4 video around the 1440 mark, x squared minus 7x plus 10. And we factored it to get x minus 5, x minus 2. In order to solve this problem, or to put our factoring to work, what we're going to do is make this equal 0. And it's always, every time we have a polynomial and we want to solve, we're always going to make it equal to 0. Let's think what this means. This means that I have some mystery number times another mystery number, and they equal 0. Think about your properties of numbers and multiplying. What do we know about one of these numbers? If I multiply two numbers and I get an answer of 0, what do I know about one of the numbers? I know one of the numbers must be 0. So let's do that. Let's make x minus 5 equals 0. I'm saying maybe this is my 0, which makes these multiply to 0. Well, if x minus 5 equals 0, x equals 5. If maybe my x minus 2 is my 0, so maybe x minus 2 equals 0. And if that's true, then x equals 2. If you wanted to check, you could put the 5 in here. 25 minus 35 plus 10 is 0. Or you can substitute the 2 back in. 4 minus 14 plus 10 equals 0 to verify that these are our solutions. But what does that even mean? Okay, so we factored, we solved, and we know that if we plug these x's in to our original polynomial, we get an answer of 0. Let's look at a graph. Looking at a picture of our quadratic, we said our equation was x squared minus 7x plus 10. We know we're going to get a parabola because the degree is 2, and this is a quadratic. But think about what our answer means. We just solved this. We factored it, and we found that x equals 5 and x equals 2 are solutions. What kind of solutions? What does that even mean, really? Let's think about this. When x is 5, if we plug that back in, we get a 0. And if x is 2, and we plug it back into the original quadratic, we get a 0. What would those zeros represent? If x is 5 or x is 2, both times we get a 0, what letter when we're graphing do we have left to be 0? Y. So if I put on our axis and I zoom in, look what we have found. Our solutions, x is 2 and x is 5, are where the graph crosses the y-axis. That's what we've solved. And if I look at these points, oh, there's the 0 we just found. We just said if we plug in a 5, we get a 0. You mean we found an xy point or an ordered pair? Why, yes, that's what I mean. And if we plugged in a 2 into our equation and got a 0, we found another point, 2, 0. So what factoring allows us to do is solve an equation. What does solving mean? Solving means we find where the graph, in this case a parabola, crosses the y-axis. So when we say x is 2, we know y is 0. We know it goes through the y-axis at x equals 2, and we know it goes through at x equals 5. And that's all we're going to do with these parabolas. Later on, you'll do a lot more with them, but
But right now we're solving them, which means we're finding where they cross the y-axis.
Let's look at another example. This is from the 1-4 factoring video about the 1540 mark. And when we factored this, we had 2x minus 5, 2x plus 3. Go back and watch the video if you don't know how to get these answers for factoring. But now we want to solve this equation. To solve it, we just make it equal 0. And again, if I have two numbers that multiply to get a 0, one number must be 0. Maybe it's 2x minus 5. Well, that means 2x must equal 5, x must equal 5 halves. But it could also be that 2x plus 3 equals 0. So 2x would equal negative 3. So x would equal negative 3 halves. I leave everything as a fraction. If you wanted to think of it as a decimal, 2.5, negative 1.5. What does that mean for our polynomial? Well, we know if we put 2.5 back in for x, we would get 0. If we put negative 1.5 in for x, we would get 0. But let's look at a graph to picture what these answers are telling us.
I've taken away our grid lines because I don't want to ruin the surprise. But here is our equation. Again, the degree is 2. That tells me that it's going to be a parabola. We factored this. We said 2x plus 3 and 2x minus 5 are the factors. We solved those for x, and we found that x is negative 3 halves and x is positive 5 halves. Let's see if my graph verifies that. So we zoom in and we zoom in. We drag it around and look at that. X is a negative 3 halves or negative 1.5. And x is a positive 5 halves or 2.5. So our graph verifies that we have our right answers, that we solved and found a coordinate pair of where the parabola crosses the y-axis.
Here's our final example, 6x squared plus 19x plus 15. And we've already factored this. If you don't remember how to factor, it's back on the 1-4 video, about 24 minutes in. When we factored it, we had 2x plus 3 and 3x plus 5. We can FOIL it always to check. 6x squared, 10 and 9 is 19x, and plus 15. But now we want to solve. We don't want to just factor, we want to solve. Again, we start that process by making this equal to 0, and we know that either one of these parentheses can equal 0. Let's make that happen. 2x plus 3 equals 0, so 2x equals negative 3, so x equals negative 3 halves. If you want to think of that as negative 1.5, that would be fine. We know that maybe 3x plus 5 equals 0. 3x equals negative 5. So x equals negative 5 thirds, and that's like negative 1.67 or negative 1.66 repeating. All right, to be more exact, this is negative 1.6 repeats. Oh, I just rounded here. Again, so factoring, and there's a lot of work involved here. I'm not going to redo the work because that doesn't matter for right now. It matters that all you're doing is continue from your factoring answer in order to solve. Set it equal to 0, which means each parenthesis equals 0. And then solve for x. Now let's look at our graph to visualize what this is telling us.
And here's our graph for this quadratic. 6x squared plus 19x plus 15. We have our parabola. Excellent. We've solved it. Let's see if we can verify what we solved for. Now we're going to have to do some zooming. Boop, boop. We said x is negative 3 halves And bingo, negative 1.5. And we also said x is negative 5/3. That's what that is, negative 5/3.
And there you have it, the purpose of factoring. Factoring lets us solve. When we solve, our answers or our values for x tell us where the parabola, when we graph, crosses the y-axis. It also tells us what values for x, if we plug into the original polynomial, give us an answer of 0. So that's why factoring is important, because it helps us solve and find the y-intercepts of our parabola.